Okay, so now we are into the second half of our trig identities, and these will be the more challenging questions. So your level 3 and level 4 questions. The first one comes from an old higher grade textbook from many years ago, and it can be a little bit of a shock if you're suddenly presented with a question like this. Because if you look at your left-hand side, sine A, there's nothing you can do with sine A, and there's nothing you can do with cos A. And so you start to feel a bit helpless saying, what am I going to do to get rid of a sine A or cos A with a plus 1 and turn it into a tan A over 2? So what we're going to do is we've got to look at things a little bit backwards. We're going to say that A over 2 is the actual angle, the alpha. And therefore, the A's are the double angles. Because if you double A over 2, you get A. All right, if you don't believe me, double A over 2. Are you happy that the 2's will cancel out with each other and you'll get A? And so it's that principle that we're working with now. So double angles and half angles kind of go together. It's the same topic, really. Okay, so I'm going to turn my left-hand side into sine double A over 2 cos double A over 2 plus 1. So now that's just a sine double angle expansion. And at the bottom, I want a cos double angle expansion. And again, I'm going to pick that choice that's going to help me get rid of the plus 1, because the plus 1 is just a nuisance. So I'm going to go for the 2 cos squared A over 2 minus 1, and then the plus 1 stays on the outside. All right, so conveniently, those two will subtract out with each other, and I'm left with 2 sine A over 2 cos A over 2. At the bottom, 2 cos squared A over 2. And happiness is divide. And we left with sine A over 2 cos A over 2, which is exactly what we wanted, tan A over 2, which is my right-hand side. Okay, so don't forget that you can take a half angle and turn it into alpha, so that your whole angle becomes the 2 alpha. It's a very nice trick to know about. Okay, next up, see what this one looks like. It's a prove that again, so it's a proper left-hand side, right-hand side story. This one actually, to me, looks like we might have to do a bit of work on both sides. There doesn't seem an obvious preference for left or right. So my left-hand side, I'm going to get a common denominator of sine B cos B. Which makes my numerator sine A times cos B to make up for the denominator, minus cos A sine B. Okay, let's see if we can take that a little bit further. Maybe we won't have to work too hard on the right-hand side. Sine cos minus cos sine, that is your sine compound angle identity. At the bottom, once again, I've got the sine cos without the 2. So it's the half sine double angle. Okay, and so the only thing left to do is to say, I don't want a half in the denominator. So when you divide by a half, you're actually multiplying by 2. And that is, in fact, your right-hand side. So we didn't have to do much more effort than that. All right. Okay, next up, hence or otherwise. Without a calculator, show that sine 5b minus cos 5b over cos b is equal to 4 cos 2b. All right, so it's a part of the previous question, just a little bit. Okay, so if I compare 7.1 and 7.2, can you see that the A has become 5B? So all my A's have become 5B's. Everything else has stayed the same. So I'm allowed to use this result to make this question a little bit quicker to do. So I'm going to say that sine A over sine B minus cos A over cos B was 2 sine A minus B. So I'm going to change this to 2 sine 5B minus B. That's the only thing that changes, is the A becomes a 5B. Okay, so it's going to become the right-hand side, 2 sine 5A, sorry, 5B minus B. The bottom will stay sine 2B. Okay, so I'm using that result, but I've replaced the A with a 5B. And this is the left-hand side. That's quite nice because now it's 2 sine 4B over sine 2B. And if I now look at my right-hand side, they're saying they don't want sine, they want cos. And they want a 2B, not a 4B. And so what I'm going to do next is I'm going to turn that 4B into a double 2B. Okay, I'm taking it slowly so that I don't leave you behind somewhere along the line. That is a sine double angle identity. So it's going to be 2 sine 2B cos 2B. At the bottom, still sine 2B. Are you happy that everything is multiplying now in the numerator? So because everything is multiplying, I'm allowed to divide. And so I'm allowed to say the sine 2b's divide out with each other. 2 times 2 is 4 cos 2b, which is indeed the right-hand side. So that is part A of the hence question. Okay, now we've got to do part B of the hence question. I haven't left myself a fantastic amount of space here for part B. All right, so now I've got to try and find another link. So can you see that these two look very similar? I've got the 4, I've got the cos, and then the 36 has to represent the 2b. So if 36 is 2b, then b would be 18. And so somehow I'm going to use the right-hand side to get the left-hand side. So I'm now moving from right to left. So if B is 18 degrees, then I'm going to say that 4 cos double 18 is going to, and I'm moving to the left-hand side, it's going to be sine 5/18 over sine 18 minus cos 5/18 over cos 18. Okay, so I haven't broken any rules. I've gone from right to left. All right, here comes the fun bit. 5 times 18 is 90. Cos 5 times 18 is 90. Okay. And you're not sure, sine of 90 is 1. Cos of 90, luckily for us, is 0, minus. And so that whole second term falls away, and we're left with 1 over sine 18, which is what we were expected to prove. So we started with the right-hand side, and we've ended with the left-hand side. And we've answered the whole question. Right, that was quite complicated mathematics and trigonometry. Okay, moving on to a slightly different type of question now. I've kind of grouped them as a 1, 2, and 3 because I think they all kind of go together quite nicely. So when you see a question like this where you have a 3a, you need to immediately break that 3a up into 2a plus a. And then it's a cos expansion, opposite sign. Okay. My choices for the cos double angle are going to be affected by what I see on the right, all causes. So I'm going to be brave and stick with the cos squared a minus 1 times cos a. Sine 2a, I have no choice. Right. So this part is starting to look good. This part isn't looking quite so wonderful. Okay, so I keep looking at my right-hand side, and my right-hand side says no sine. So it's this sine squared a that's the problem. So if you go through all the options that you've got for getting rid of that sine squared, your best option is your grade 11 identity, 1 minus cos squared. Nearly there, I'm going to leave this alone. Over here, be careful. I've got to multiply the minus 2 into the bracket and the cos A into the bracket. And so minus 2 times cos A times 1 gives me minus 2 cos A. And then minus 2 times cos A times minus cos squared A gives me plus 2 cos cubed A. Okay, minus times a minus is a plus. Finally, I have beautiful like terms that I can add together to get exactly what I wanted. Isn't it lovely when you get what you want? And that is the right-hand side. Okay, so that's type 1 of these expanding type questions. Here's the second one. Maybe you've seen this one before, maybe you haven't. So the left-hand side is hectic, the right-hand side is just equal to 1. So somehow I've got to simplify the left and get to 1. As tempting as it is to work with the 2 sine squared A, that is actually the simplest angle because it's just A. Here we're sitting with a 5A, a 3A, and an 8A. And so I would not mess with the 2 sine squared A. And remember, because it's not an identity, you can't take things across the equal sign. Not that we ever actually do that mathematically anyway, but we may not move across the equal sign. So I'm working with my left-hand side. And the thing that I notice is if I look at those numbers, can you see it's not a coincidence that that's a 5 and that's a 3 and that's an 8. So what I'm going to do, because I'm trying to get common angles or something, I'm going to take that 8A and I'm going to turn it into 5A plus 3A. Okay, and this is going to be scary now because we're going to have to expand. And often when you expand, you feel like you must be doing the wrong thing because the question gets so long. So it's going to be cos minus sine. And that poor little 2 sine squared A is just hanging on there. All right, now here's where it gets interesting. If I multiply the minus or the minus 1 into the bracket, can you see that this is 2 cos 5A cos 3A minus 1 cos 5A cos 3A? And so those are like terms, and 2 minus 1 makes 1. Then minus times a minus makes a plus sine 5A sine 3A, and patient little 2 sine squared A is still hanging on. Okay, now look, there's more magic. Because that's an identity. It's your cos, sine. So it's the cos 5A minus 3A, which is fantastic because it's cos 2A. And now we have absolutely no doubt what we're going to choose there. We're going to go with the 1 minus 2 sine squared A. And we're left with 1. Okay, so if you haven't seen one like that before, now you have. You can't be caught out. I've seen it with 6 and 4 and 10. So there are other variations of this question that you need to watch out for. Okay, we're nearly there. The next one is the nasty version. And I call it the nasty version because they're going to mess with us a little bit here. There's a 7a, and here's a 4a and a 3a. So your first instinct is going to be, let me take the 7 and break it into 3a plus 4a. But you're going to run into trouble because of that random cos a over there. And so you can try it, but I guarantee you're going to get stuck. So I'm going to show you a different alternative here. And the different alternative, it took me a couple of tries before I was happy that I was doing the right thing. So don't assume that it just comes easily to everybody. What I chose, instead of breaking the 7 up into something plus something, I made it 8a minus a. And the only reason I felt comfortable doing that is I realized that when I expanded it, I was going to get a cos a. And I thought maybe I can do something with it. So this is going to be cos plus sine plus cos a. Okay, so poor little cos a is just hanging around over there. All right, now when I look at my right-hand side, I see the 4a. And so I think, okay, these 8a's are double 4a's. So I'm going to make this cos double 4a and sine double 4a. And then I'm going to do the cos expansion. And I'm going to stick with the cos. So I'm going to go 2 cos squared 4a minus 1 times cos a. My reasoning being that maybe the minus cos a and the plus cos a will cancel out with each other. The sine, I have no option. 2 sine 4a cos 4a times sine a plus cos a. By now you must think that this woman has completely lost her marbles, but let's look at the next step. So this is going to become 2 cos squared 4a cos a minus cos a. Hooray! Plus 2 sine squared 4a cos 4a plus cos a. And eventually, I've got rid of those. And now it feels like maybe I stand a chance of something worthwhile over here. Okay, let's see. What have I got? I've got a cos squared 4a. Here I've got a cos 4a. So maybe I've got to take out a cos 4a as a common factor because that's actually all that's common. When I do that, I'm left with 2 cos. Oh, wait, I can take out a 2. Let's take out a 2. So then I'm not going to have this 2 in the bracket. Sorry about that. So now I've got cos 4a cos a plus sine this is not sine squared. I do beg your pardon. So it's going to be sine 4a sine a. Sorry, I did turn that into a bit of a mess. Okay. So what have I got? 2 cos 4a. I'm just going to neaten it up. Cos 4a cos a plus sine 4a sine a. And that looks like an identity. 2 cos 4a. This will become cos 4a minus a. Wonderful. 2 cos 4a cos 3a. All right, so just to make that look a little bit neater, taking you back to this step, it's a sine 4a cos 4a times a sine a. The angles are different, and so we have to keep them all in a long string. Okay, and all we could take out was the cos 4a as our common factor. Okay. This is feeling a little bit long, I know, but I have one more to show you. So let's do this very last one, and then you can breathe. Okay, this is quite an unusual looking question. So on the left, we've got cos to the 4 and sine to the 4. And on the right, and those are single angles, and on the right, we've got a cos squared, and it's a double angle. So it's a little bit difficult to decide which side to work with. You could try and work a little bit with both sides. I'm going to go from the left-hand side just because it's got 2 terms. And I'm going to start by taking out a common factor of 2 so that I have a little bit more focus on what's in the brackets. And now when I look at what's in the brackets, it's not what I'm used to. I know that sine squared plus cos squared is equal to 1. And I wish that I could just say this is sine squared plus cos squared squared. It isn't, but I'm going to use that knowledge. So this is really coming in from outside the box. I'm going to say this is like cos squared x plus sine squared x squared. But if I actually go and square that binomial, remember I'm going to get a middle term, and the middle term will be 2 cos squared x sine squared x. So because I added in a middle term, it's like completing the square, I have to take out that middle term. Okay, I've got to be very careful with your brackets here. So now, this is just 1. So I've got a 2 outside the bracket. My first bracket becomes 1, because remember 1 squared is still 1, minus, and then I've got 2 sine squared x cos squared x. Be careful not to do silly things over here. Okay, what I'm going to do instead is I'm going to multiply the 2 into the bracket. And this gives me 4 sine squared x cos squared x. If I didn't get the 4, I would have been stuck. But because I got the 4, I'm going to say this whole term is 2 sine x cos x all squared. Okay, look at that carefully. If I square this bracket, are you happy that I'll get back there? Okay, so now what I have is 2 minus this over here is sine 2x, but squared. And now you're going, but wait, you wanted cos squared and you've got sine squared. All right, so the good news is I can go one step further. I'm still going really outside the box. I'm going to take that 2 and I'm going to make it 1 plus 1. Okay, right back in grade 1, you learned that 1 plus 1 is 2. And would you agree that now that is an identity? So to finish off, that 1 stays on its own. This becomes cos squared 2x. And that is equal to my right-hand side. Okay, so remember 1 minus sine squared is cos squared. Be careful not to see it as a 1 minus 2 sine squared x. It's not. It's a 1 minus sine squared angle, which becomes a cos squared angle. Right, I hope that that gives you a little bit more insight into some of those really high-level trig identities questions. And what I hope is that you tried them yourself and then had a look at the solutions and that everything now makes perfect sense to you.